All right, so tomorrow we have a test, and let's review for Unit 12 test, our last test for the year before finals. So permutations and combinations, questions 21 through 24. Now permutations, I'm gonna say 7 factorial. You guys see where I get my 7 from, over 2 factorial. Now the 2, because I subtracted 7 minus 5. Remember, what does 7 factorial means is 7, starting at 7, multiplying by every number going down up to 1. So 7 times 6 times 5 times 4 times 3 times 2. I'm going to call this 2 factorial. And the reason why I stop at 2 factorial, because I already have a 2 factorial at the bottom. So I'm just looking at 2 factorials canceling out. I'm just going to say what 7 times 6 times 5 times 4 times 3. Let me grab a calculator for that. 7 times 6 times 5 times 4 times 3. I happen to get 2,520. Now, 22, question 22, I'm going to do 7 factorial over 1 factorial. So what does 7 factorial means? I'm just going to go 7 times 6 times 5 times 4 times 3 times 2 times 1. Because 1 factorial is 1. So they basically cancel out. So I have 7 factorial basically. I'm just going to grab my calculator. And I'm just going to go 7 factorial. I have the factorial thing. So instead of going 7 times 6 times 5 times 4 times 3 times 2 times 1, I did 7 factorial, gives me 5,040. So 5,040. Now combinations or choosing, so people call it choose. Now these are a little bit different, just a tad different. I'm going to start to begin with on number 23. I'm going to put 16 factorial over. So I'm going to start kind of like how I did permutation. So 16 factorial over 12 factorial. Now, the only thing though is that here I'm also going to include a 4 factorial at the bottom. All right, so let's take a look. My 16 factorial, that is going to be 16 times 15 times 14 times 13 times 12 factorial. I'm going to stop at 12. The reason why, because I have a 12 factorial at the bottom. No, they're going to cancel out. Now, my 4 factorial that I have at the bottom, I have 4 times 3 times 2 times 1. Remember, my 16 factorials cancel out. So for the top, I have 16 times 15 times 14 times 13. That's what I have on the top. Divided by, I'm going to use parentheses for the bottom. At the bottom, I have 4 times 3 times 2 times 1 equals 1,820. Take a look at number 24. I'm going to start with 13 factorial, my 6 factorial. Remember 6 because I subtracted 13 minus 7. But at the bottom, I'm also going to have a 7 factorial. So here I'm going to start this as 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial. I stop at 7 because I have a 7 factorial at the bottom. Now at the bottom, I also have a 6 times 5 times 4 times 3 times 2 times 1. So let me grab my calculator for that. So 13 times 12 times 11 times 10 times 9 times 8 divided by, at the bottom I have 6 times 5 times 4 times 3 times 2 times 1. I'm not going to do that times 1 equals 1,716. Simple. Expect on the test one permutation and one combination. So that's already 2 questions from the test. There's a total of 10 questions. So that's not that bad. Let's take a look at question number 25. For 25 and 26, To state if each scenario involves a permutation or a combination. Permutation, the order does not matter. I mean, the order does matter. In combination, the order does not matter. Sometimes combination people call it choose. Then find the number of possibilities. All right, Wilmer and Laya are planning trips to 3 countries this year. There are 14 countries they would like to visit. One trip will be 1 week long, another 2 days, and the other 2 weeks. So there are 14 countries they would like to visit. So I'm just gonna say, well, Wilmer are planning trips to 3 countries. So permutation. I want to use permutation because it does matter. One of them is 1 week long, the other 2 days, the other one 2 weeks. So it does matter. So permutation. So to begin with, I'm going to say permutation. From 14 countries that they have, they're going to visit 3 of them. So 14 permutation 3. So what does that tell me? 14 factorial over 11 factorial. I know 14 factorial is 14 times 13 times 12 times 11 factorial. I stop at 11 because I have at 11 factorial at the bottom. Let me grab my calculator. I'm just going to go 14 times 13 times 12, and I have 2,184. But first of all, I had to say it was permutation, and then I use my colon there, and I'm going to type in 2,184. Make sure whenever you guys type it, permutation has a capital P. Make sure after the colon you guys have a space. Let me emphasize, I have one space there. When you guys type it, that's how it will have to be typed. All right, now let's take a look at number 26. Azanji and Anjali are planning trips to 6 countries this year. There are 9 countries they would like to visit. They are deciding which countries to skip. So there are 9, and they're going to skip 3. Now this one, it doesn't matter which one they go to first. So we're going to say combination. So my answer, I'm going to start with combination, colon. There's 9 countries, and they're going to skip 3. So I'm doing 9, choose 3. So I'm just going to do 9 factorial over 6 factorial. And at the bottom, I also have a 3 factorial. So I have 9 times 8 times 7 times 6 factorial. I stop at 6 because I already have a 6 factorial at the bottom. At the bottom, I also have a 3 times 2 times 1. Let me grab my calculator. So on the top, I have 9 times 8 times 7 divided by, technically the top is 6, right? 3 times 2 times 1. So that gives me 84. From these, expect one on the test. Let's take a look at 27 and 28. Find the probability of each event. Mary and Stefan each purchased 1 raffle ticket. If a total of 11 raffle tickets are sold, what is the probability that Mary wins the grand prize and Stefan wins the second prize? The order does matter, right? Because we want Mary to win the grand prize and Stefan to win the second prize. So order does matter, so we're using permutation. Now, so I'm gonna say we're using permutation. There's 11 tickets, and basically we want 2 of them. Now, this thing is gonna give us how many possible ways there are. So 11 permutation 2, that's what? 11 factorial over 9 factorial. Now 11 factorial is in that 11 times 10 times 9 factorial. I have a 9 factorial at the bottom. So 11 times 10 is 110. Now keep in mind, this is how many possible ways the tickets can be rearranged. But Obviously, Mary just got one ticket. Stefan just got one ticket. So my probabilities that they're gonna win this way, I'm just gonna say is 1/110. Question number 28. A chemistry lab requires students to identify chemical compounds by using various tests. Each student is given samples of three different compounds labeled A, B, C. So I have three things I had to find out. Each student is also given a list of 10 possible compounds. If a student does not perform the test and randomly chooses three from the list, what is the probability that she guesses all three correctly? Now, order matters, right? What it says here is that student has to choose three, label A, B, C. There's 10 of them, but order matters, right? Which one is A, which one's B, which one is C? Order matters. So I'm gonna be looking at permutation here because order matters. From the 10 that the student has, this person has to choose three. So now this thing is 10 factorial over 7 factorial. Now what does 10 factorial mean? It's 10 times 9 times 8 times 7 factorial over 7 factorial. Now 10 times 9 times 8 on the top, I have 720. So there's basically 720 possible ways to rearrange these. Now the student has to answer correctly, right? There's only one correct solution. So what is the probability that the student guesses all three correctly? Is 1 out of 720. To put three in order out of 10 doesn't seem like you can. It seems like you can easily get it, but you can see that you're gonna get 1 out of 720. As a hint, do study for your test. Now let's take a look at number 29 and 30. Oh, for 27, 28, expect one of those on the test. Now 29 and 30, we're gonna review the binomial theorem. So our second term in expansion of 2b minus a to the all to the seventh power. So if I started counting at 0, I'm asking, all the way to 7. I'm going to see which one is my second number. Okay, so now this is important. Now, first thing I'm going to say is my second term is going to have a 7, choose 1. My first number. And I have a 7, choose 1. You see where I got my 7, right? My exponent was 7, and you see where I got my 1. So 7, choose 1. My second thing is going to be 2b. My second term is going to be 2b, and my last term is going to be negative a. Now, my b, my 2b is going to be to the 6, and my negative a is going to be to the 1. All right, so how do I choose the exponents on 2b and negative a? You can see where I got the 2b to begin with, and you can see where I got the negative a to begin with. But how do I choose the exponents? Starting at 7, which one's and going down, which one's the second number? That's how I choose the exponent for the first one. For my last parentheses, I said starting at 0, going up, which one is my second number? Okay, that's how I chose this. So let's see. 7, choose 1. I have 7 factorial over 6 over 1 factorial. So 7 factorial times 6 factorial over 6 factorial, 1 factorial. 6 factorials cancel out. That is basically 7, right? So my first parentheses is 7. My second parentheses, what's 2 to the 6? 64. So I have 64b to the 6. And the last one, what's negative a to the 1 power? Negative a. All right, let's combine our numbers. When I say combine our numbers, I'm talking about a 7 times 64 times a negative 1. So it's going to give me negative 448, numbers wise. Letter wise, b to the 6 and a to the 1. How do you type this? Negative 448 b to the 6 a. All right, let's do binomial theorem again. Starting at 0, I'm going to go up. I'm going to start counting. 0, 1, 2, 3, 4, 5, on and on. I want to know which one is my sixth number. Okay, using this 5 up here, my first number is going to be 5, choose 5. My second parenthesis is going to be y. The second parenthesis is going to be 2x. Now, starting at 5, going down, what's my sixth number? Starting at 5, going down. So 5, 4, 3, 2, 1, 0. What's my sixth term? 0. Now, starting at 0, going up, which is my sixth term. Okay, so 5, choose 5. Let's do that one first. 5 factorial over 0 factorial, 5 factorial. These 5 factorials cancel out, so I have 1 over 1. 0 factorial is 1, so I have 1 over 1, which is just 1. So easy. The first parenthesis was 1. Y to the 0. Isn't that just anything to 0 is just 1? We have no more y, just 1. Now, 2 to the 5th, that's 32. And then x to the 5th. Let's multiply our numbers. 32 times 1 times 1. That gives me 32. X to the 5th. How do you type this? 32 x to the 5th. Easy. Expect one of these on the test. Now here, determine if events A and B are independent. Now, independent is if probability of A times probability of B is equal to probability of A and B. That's how we know they are independent. So let's take a look. I'm asking here, is 9 over 20 times 7 over 20 equals to 63 over 400? Let's see. On the top, on the left side of my equal sign, 9 times 7 is 63. 20 times 20 is 400. Is 63 over 400 equal to 63 over 400? Yes. So in this case, these are independent. Remember I said it's independent if probability of A times probability of B equals probability of A and B. Let's take a look at number 32. 2 over 5 times 1 over half, is it equal to 4 over 25? Let's take a look on the top of the left of my equal sign. 2 times 1 on the top. At the bottom, 5 times 2. Is 2 over 10 equal to 4 over 25? No, it's not. Because I could simplify. This is 1/5. That's 4 over 25. Yeah, they're not equal to. So in this case, these are dependent. Expect one of these on the test. Let's take a look at review questions 33 and 34. Now, here I'm going to say probability of A times probability of B is equal to probability of A and B. Because they are independent. That's the formula I'm going to use. So what do I have here? Probability of A is 3 over 10. Probability of A is 3 over 10. Probability of B, I don't know what it is. I'm just going to call it X. Probability of A and B is equal to 3 over 50. So the way I'm going to have x by itself, I'm going to multiply both sides by 10 over 3. I'm going to multiply by the reciprocal of the fraction that is with the x. That way these 10s cancel out, these 3's cancel out, and I have x by itself. Now here, these 3's cancel out. 10 and 50, I simplify them and they become 1 and 5. Now when I multiplied, I get 1 over 5. When you type it, just type in 1, 1/5. Take a look at number 34. I have probability of A is 3 over 10. Probability of B, I don't know what it is. Probability of A and B is 21 over 200. So the way I'm going to have x by itself, I'm going to multiply both sides by 10 over 3. So these 10's cancel out, these 3's cancel out, and I have x by itself. Now here, the 3 with the 21, they become 1 and 7. I divided each by 3. The 10 and the 200, they become 1 and 20. I divided each by 10. So when I multiplied straight, I have 7 over 20. So my probability of B is 7 over 20. Just type this as 7 over 20. Notice that on questions 33 and 34, as well as 31 and 32, I'm using times probability of A times probability of B. And the reason why, because I have in both cases, I have the word and. Every time you have and, you must use times. All right, so let's take a look at 35 and 36. Now here, I'm just gonna say for question 35, since I have to deal with probability of A, I'm gonna say probability of A times, and I'm using times because I see the word and being used. So times probability of B not A is equal to probability of A and B. All right, so what's probability of A? I don't know what it is. I'm just going to call it X. What's the probability of B not A? It's 3 over 20. And this is equal to probability of A and B is 9 over 80. The way I'm going to get the X by itself, I'm going to multiply both sides by 20 over 3. That way these 20s cancel out, these 3's cancel out, so I get X by itself. On the right side, the 3 and the 9, they become 3 and 1. I divided each by 3. The 20 and the 80, let me divide each by 20, so they become 1 over 4. When I multiply straight, I get 3 over 4. So when I expect you guys to just type is 3 over 4. Take a look at number 36. I'm going to use, since I'm dealing with probability of B by itself, I'm going to do the formula probability of B times, I'm using times since I'm using the word and, probability of A not B is equal to probability of A and B. All right, probability of B, we know it's 1/5. Probability of A not B, I don't know what it is. I'm just going to call it X. Probability of A and B is 1 over 20. The way I'm going to get the X by itself is if I multiply both sides by 5 over 1. That way these 1's and these 5's cancel out, so I have X by itself. Now 5 and 20, let me divide each by 5. When I multiply straight, I get 1 over 4. So my answer will be 1 over 4. That's how you guys will end up typing it. Easy. Expect one of these on the test. Now looking at 37 and 38, I'm using the word or. So I don't have and anymore, I have or. Now how am I going to do this? I'm just going to say probability of A plus probability of B is equal to probability of A or B. And if that's true, these are mutually exclusive. If it's not true, not mutually exclusive. So let's see, probability of A, I have 1/2. Probability of B, I have 1/4. And it says is equal to 3/4. Let me even put a question mark. I need common denominators. I need a 4 at the bottom. So my first fraction, I'm going to multiply top and bottom by 2. So that gives me 2/4 plus 1/4. And I'm wondering if this is equal to 3/4. Since the denominators are the same, I'm just looking, is 2 plus 1 equal to 3? If that is true, then these are mutually exclusive. All right, let's take a look at question number 38. I have that 1/2 plus 1/4 is equal to 7/10. Put a question mark on the equal sign because I'm wondering if it's true or not. I need common denominators. So 2, 4, and 10, I can easily make them all 20. I'm going to multiply the first fraction by 10. I'm going to multiply the second fraction by 5. I'm going to multiply the last fraction by 2. So I have 10/20 plus 5/20. It says is equal to 14/20. I made the common denominator, so now my question is, let me put a question mark here. What I'm asking is 10 plus 5 equal to 14? Because it's not true, I'm going to say not mutually exclusive. Expect one of these on the test. Lastly, find the standard deviation for each data set. So what I'm going to do, I'm going to add my numbers. Um, First of all, I need to find the mean of my numbers here. So I'm going to just add them all up. Let's see, my numbers are 2 plus 2 plus 2 plus 3 plus 3 plus 2 plus 5 plus 2 plus 2 plus 2 plus 4 plus 4 plus 5 plus 2 plus 5. All right, there's 15 numbers I just added. And it says I just added them all, and it's 45. Now my average, because I'm going to go 45 divided by 15, because there's 15 of them, my average is 3. I've been using the Greek letter mu for average, so my average is 3. I just added them all, divided by how many I had. So I'm just going to go, for my first case, I'm going to go 2 minus 3, and I'm going to square that, and that gives me 1. For the second number, I'm going to go 2 minus 3 squared gives me 1. 2 minus 3 squared, that gives me 1. Now for my third number, I have 3 minus 3 squared, that gives me 0. Then I have a 0, 1, 4, 1, 1, 1, 1, 1, 4, 1, 4. Okay, how did I get these values? I went each number subtracted by 3 and then square it. So it gave me 15 numbers, right? 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Find the average of these. All right, so I just added them all. Happen to have 22 divided by 15. That gives me my variance. My variance is about 1.46666666. Let me get the square root of that, and I get 1.21. All right, so let me go again. What did I just do? What I did was I added all my numbers. I added all 15 numbers, divided by 15. That's how I got my average. And I found out my average was 3. Then what did I do? Each of my numbers, I subtracted by 3 and then square it. And then I got the average of that. And then at the end, I got the square root of it. Okay, so let's take a look at question number 40. Let me add my numbers. Let's see, I have 68 plus 68 plus 67 plus 73 plus 71 plus 64 plus 69 plus 68 plus 77 plus 67 plus 64 plus 77 plus 68 plus 72 plus 71 plus 69 plus 75. So those are 17 numbers that I just added. I added all my numbers and it gave me 1188. So once again, I added all my numbers and I have 1188. I'm going to divide this by 17 because there's 17 of them. So I get that my average is, my calculator shows me 69.8825. Okay, so I'm going to do each of my numbers. So I'm going to do 68 divided by my average. Let me just say 68 minus my average and square it. My second number, I'm going to go 68 divided by my average and square it. And I'm going to go 67 minus the average and square it. Then I'm going to go 73 minus the average and square it. I'm going to do that to each of my numbers. And I have, let's see, 3.5432. Then I have 3.54325. Then I have 8.30796. I have 9.71972. I have 1.24913. I have all my numbers. I'm going to add them all up and then divide it by 15. That's going to give me 14.4567. Let me get the square root of that. And I'm going to call this 3.80. Just going to have one of these on the test tomorrow.